Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video, I'm going to show you how to fine tune a large language model for your specific use case. So we will be working with DeepSeek R1 LLM, and DeepSeek R1 comes in various sizes, and their lightweight model, their smallest and lightweight model is 1.5 billion parameter model, and their largest model is the model which have 671 billion parameters. So in my today's tutorial, we will be fine tuning 7 billion parameter variant of DeepSeek R1, and to fine tune this model, to fine tune the model of this size, we need a GPU with at least 48 GB of VRAM. We need 8 to 16 CPUs, and we need a RAM around 64 GB to 128 GB, and then we need a storage of 300 to 400 GB. So this kind of hardware I don't have in my local machine, so I decided to show this fine-tuning process with a cloud GPU service. And we know that the popular GPU cloud services are AWS, Google Cloud or Azure, but they are very expensive. So recently I discovered a more affordable platform called ThunderCompute. They offer GPU access at just $0.27 per hour, and I recently tried their service for one of my project and I was quite satisfied, which is why I decided to use ThunderCompute for this tutorial. I initially tried ThunderCompute because of the free credits. They give $20 free credits to new users, but after having a smooth experience, I went ahead and then I purchased more GPU hours. And most importantly, the setup was very easy. So that's why for fine-tuning our LLM, I'll use this cloud GPU service. See this page here. This is the official website of ThunderCompute, and if you'll see this quick start over here, you can see that we can use ThunderCompute cloud services in two ways. First is VS Code through VS Code extension, and the second option is CLI. In this video, I'll show you how to use VS Code option, and I'll connect the GPU from cloud to my local VS Code editor, and then we'll start working. First step is to install VS Code, and if you don't have it already, then you can download it and install it. Go to the official VS Code website, click download, and as per your machine, if you're working on Windows, then click download for Windows, and then run the downloaded .exe file and follow the installation steps. And once you install VS Code, next step is to install extensions. So let me open VS Code over here. So this is the VS Code, and here this is what extensions look like. You have to click on this icon. Okay, so click on this. Here you will see two options, installed and recommended. I am clicking on this installed, and here you can see all the extensions which I have installed. You first need to install the Python extension because we will write the code in Python today. So you need to install the extension. For that, you will just type Python over here in extensions, and you will see the extension over here. In my case, it is already installed. In your case, you will see the install button over here with the extension. Just click on it, and this extension will be installed. So this is the first extension which you need, and the second extension which you need is remote SSH. So you will see the extension over here. In my case, I have already installed it. In your case, you will install it. So these are the two extensions which you need before starting our today's tutorial. Okay, now the third step is to use VS Code, to use ThunderCompute GPUs with VS Code. They have mentioned that you need to install the ThunderCompute VS Code extension. So for that, you will click on it. When you will click on it, it will ask you to open Visual Studio Code. Just click on it, and here you will see the extension. In my case, I have installed it, so that's why you are seeing uninstall over here. In your case, if you are doing it for the first time, you will see the install over here. You will click on it, and then ThunderCompute extension will be installed. Once this extension will be installed, you will see this over here. See this kind of icon over here. So this is a ThunderCompute. So you have ThunderCompute extension now. Now you will click on this extension, and here you can see the instances. So with this extension, we can create, start, stop, or delete, or connect to ThunderCompute GPU instances. Now I'll show you all the steps one by one. So to create the instance, you will click on this plus over here. It will show you various GPUs and other necessary resources like memory and CPU. You can select as per your requirement and then click on create instance. So in my case, see, the GPU I have selected is NVIDIA A100 80GB VRAM GPU. And I have selected 2 such GPUs, and the number of CPUs I have selected is 16, and the storage I have selected is 1000 GB, and then click on this create instance. Now we have created an instance. Now the next step is to connect with this instance. Now open terminal in VS Code. Now you are inside the remote ThunderCompute server, and here we will perform all those steps which we need to fine-tune the LLM on cloud GPU service. So the first step is to install all the required packages. So first of all, we will install and update all the basic libraries. So this is how you can do it, and run this command. Once you run this command, and now you have all the base packages and you have updated all the packages. Next step is to install some other basic libraries like git, wget and unzip. So we are installing them by using this command. So install it. Now guys, the next step is to check the Python version. If Python is installed, then we'll continue from the next steps. Otherwise, we will install the Python first. So I have checked the Python version, and you can see the Python version is this. So Python is installed. Now I will create a separate environment, because guys, I always prefer to work under a separate environment, and using this command, you can create a separate environment. So once you create the environment name is DeepSeek-env. Now we need to activate the environment, and to activate the environment, you will write source, then the environment name, bin, and activate this command. Okay, hit enter. Now the environment is activated. You can see it over here. Now we will install all the deep learning libraries. What we want to fine tune the LLM, and to fine tune the LLM, we need Torch Vision, Torch audio packages. We need transformer package from Hugging Face, right? Like this, we need some packages. So we will install all those packages. So first I'm installing Torch Vision and Torch audio with CUDA 12.1. So this is the command. When I hit enter, these packages will be installed. Now we have installed these packages. Next step is to install transformers package, then dataset package, accelerate and PEFT. These kind of packages we need. So I'm installing all these packages now. Why we need transformers package? Because we will use the DeepSeek R1 model weights from this Hugging Face. So to access the model from Hugging Face, we need transformers module, and then datasets module. Why we need it? Because for fine tuning the dataset which I'm going to use, I'm not creating my own dataset. So for this tutorial, I'm just using the dataset which is already available in datasets module. So that's why I'm installing this package. And then we need PEFT package, because we will be fine tuning our LLM, and to fine tune the LLM, we need PEFT library from Hugging Face. Using that, we will use LoRa to fine tune the LLM. Okay, so these are the packages we need. Hit enter, and now we have all these packages installed. Our environment is ready now. Next step is to download the DeepSeek R1 7 billion model. So we want to get this model, we want to pull this model from Hugging Face Hub. So also need to install the Hugging Face _hub, this package. So we are installing it, and then you need to log in, because guys, to pull the package, to pull the model from Hugging Face, you need to provide your API key of Hugging Face, and you need to log in first. This is how you can log in: Hugging Face -CLI login, and here you will paste your API key. So for that, you need to get that API key from your Hugging Face account. Okay, paste that API key over here and then hit enter. Now you can see here that you are logged in. Now I'm going to show you the code to fine tune the model. Okay, then we'll come back to this step again. First, let's understand the code which we will be using to fine tune the model. So this is the script. The link of this code is given in description section. You can get this code from there. First, I'm importing all the required modules. See, we are importing torch and transformers. I have told you why we need transformers, because the model which we are going to pull today, we are going to pull that model from Hugging Face, and for that we need it. And then we are importing PEFT because we want to perform fine tuning, and for fine tuning we will use LoRa. So for that you need this PEFT module. We are importing this load dataset from dataset, because the dataset which we are going to use is a ready-made dataset. We will load the dataset, okay? And this is just to show the progress bar. So first we are mentioning the name of the model which we want to use, which we want to pull from Hugging Face. So this is the model name, and then we are loading that model. So what we are doing is, the model name we are getting from here, config this from here, and then the device map. CUDA 0 means the model which we are going to pull from Hugging Face. I want to load that model on first GPU. Okay, so we are using 2 GPUs. Remember, while creating instance, we have used 2 GPUs. So I'm mentioning over here that I want to upload that model on the first GPU. And this float 60 means, this simply means, float 16 means this is for memory efficiency, right? So we have loaded the model, and then here we are loading the tokenizer also. Which tokenizer? The tokenizer which is used with this model, the same tokenizer we are downloading. Why we need tokenizer? Because model don't understand the alphabets, words as it is, so we need to convert them in some sort of numbers, in some sort of IDs. For that we need tokenizers. Okay, so this is my tokenizer, and this is our model. We have loaded both model and tokenizer. Now the next step is to load the dataset. So the dataset which I'm using is this dataset, alpaca dataset, and then this function is just to format the data in specific format, like user, and then instruction, then assistant, and then this instruction, the response of the boot. Okay, so after that we are tokenizing the dataset. Whatever dataset we have loaded, we need to tokenize the dataset first. So that's what I'm doing over here. Once you tokenize the dataset, now here we are writing the code which is needed to fine tune the model. And for that, what we are doing, we are using LoRa, and these are the 2 layers which we are modifying. So guys, in my today's tutorial, I'm not going to explain the LoRa in detail or fine-tuning concept in detail. So what I'm just telling you is that using LoRa you can fine-tune the model, and using LoRa we are just working with these 2 layers. We are modifying these 2 layers, and these 2 layers are present in attention blocks. And now our LoRa configuration is ready. And then get PEFT model. What we are doing is, we are providing our model, the model which we have loaded above, and then the LoRa configuration which is over here, and then we are fine-tuning our model in this. And after that, this is the training steps. We are defining all the arguments which we want to use while training our model. So we want to train the model for 3 epochs, and FP16 is true. That means this is for memory efficiency. Save steps 500. What it means is that after every 500 steps we will save the checkpoint. Okay, I'll show you that in some time. First understand the code. I'll show you the training process on GPU also in some time. And that's it, guys. These are the training arguments. So we are training a model for 3 epochs, and then this is the trainer. We have created the trainer. Now we will start the fine-tuning process. So guys, first, when I executed this code for the first time, I used this. So this means we are training from scratch. Scratch simply means over here that we are taking that base model, and then we are using our custom dataset, and we started the training. But due to some reason, I had to stop the training process in between. So then my previous checkpoint was this checkpoint 4500. So then I resumed my training from there. Okay, so this is how you do that, and after that, once your model get trained for 3 epochs, we are saving that model in this location, and the tokenizer we are saving at this fine-tuned tokenizer, and this is the fine-tuned model. Once you save these fine-tuned models, you can download these models to your local machine and then you can use it. So let me show you here. See, after fine-tuning, I downloaded that fine-tuned model on my local machine in E drive in this folder. I downloaded that model over here. Now you can use this downloaded model in your local machine, right? So what we have done, we fine-tuned the model on with the help of cloud GPU services, and then we downloaded that fine-tuned model on our local machines and we can use it. Okay, so this is how you can do that. Now let's see the training process. So first, see guys, this is the code I have shown you. See, this is the file which I have shown you. Right now this file is on my local computer. We need to send this file, we need to upload this file where? We need to upload this file to the remote server where our GPU is. And how you can do that? For that, you will open a command prompt. So this is the command prompt. Go to the drive where your code is, and I have a code in this folder and I have a separate environment in it. Let me activate that environment. And here guys, just go back to their website and see. They have mentioned that we can use ThunderCompute in 2 ways. One is through VS Code, the process which I'm showing you already, and the another one is CLI. Now what I'm doing is just to transfer the files from your local computer to the remote server, I'm showing you how to use CLI also. Just click on the CLI and see, you need to log in, and you need to log in like this, TNR login. Now first you need to, if you are using it for the first time, you need to install the TNR package, and you will install it like this, pip install TNR. In my case it is already installed, right? In my case it is already installed, and the second step is to log into it, TNR login. And if you are using it for the first time, it will ask you for the API key, and you can get that API key from this TNR website. Just click on this console and you will be redirected to this page. And from this page, just go click on this settings, and from this API tokens, click on this API tokens, and here you will get your API key. Okay, so if you are a first time user, you need that API key, and you will fill that API key over here. It will ask you to fill the API key, and once you fill it, you will be logged in. In my case, I'm already logged in. Now I'll write a command over here to transfer the file from my local computer to the remote server. So this is the command, TNR SCP. Using SCP you can transfer the files, and this is my file on local computer. Okay, so this is the file. Let me show you this file again. See, in E drive, inside this folder, so we are already in this folder, so that's why I'm writing the file name directly over here, and then give a space, and here you will write the path where you want to upload this file. So what this 0 means, go to their website here again, and you can see here, and this is my instance is running, and we are using these 2 GPUs. Template is base, right? And here see ID, under ID we have 0, so this 0 ID we have mentioned here. Write the instance ID and then the path where you want to upload it. Now how do I get this? Let's see. See here, just write pwd, so you'll get the present directory, home Ubuntu, and the instance ID is 0, so that's what I've done. Just write TNR SCP in the file from your local computer, and then here you'll write the path like this and hit enter. When you'll hit enter, you will see the file, that file over here. See, successfully transferred one file. So now you can see that file over here. See on this side, and if you want to see here, just write ls and you can see the file name over here, right? You can see that file over here, and now we have uploaded that file, our code, fine-tuning code, on the remote PC. Now we will run this code and we can see the output. So this is how you run this code, and now the fine-tuning process started, you can see. And once the fine-tuning is finished, you can see the saved model in this folder here. See this folder over here? Here you will see your fine-tuned model, this. Now we can zip this file and we can download it, and this is how you can zip it. And now you'll see the zip file over here on the side, and now just right click on it and then you can download this file on your local computers. This is how you fine-tune the model. Now if you want to load this model and you want to perform inference with it, you want to see if this model is fine-tuned model is working correctly or not, then we have our inference script. Let me show you that script now. So this is the script. First we are here mentioning the base model, the model which we downloaded from Hugging Face, right? And then this is the adapter path. Adapter path means our model which we have saved, okay? After that we are loading the model, and this is how you load the model. After that we are loading the LoRa adapter and we are loading the tokenizer. Then we are using the model in evaluation mode, and then this is the inference function, chat function, input text. So this is the prompt, and input will go to the tokenizer. Tokenizer will tokenize that input, and then it will work on it. That input will go to the model will generate the response on it, and then we are decoding that input. And here you see we are running the code. So user input. So let's say this is the question which user asked, explain how transformer works in simple terms. So this is the question which user asked, and this question will go to the chat function. This chat function, in this chat function we are using the model tokenizer and the LoRa adapter, and then our final response we are showing on the screen. Okay, now this code is on my local machine. We need to send this code, we need to upload this code to the remote server. Let's say you want to test it on remote server, then you need to upload it to the remote server, remote machine, then you can test it. Or you have downloaded the fine-tuned model on your local machine, and for inference you can try it on your local machine, right? So let me upload this code on the remote machine and then we'll test it. So our file name is inference DeepSeek R1. So just go to the command prompt of your local machine again. You will use the same command, just change this name. What is the name of our code? Inference _ DeepSeek R1. So just write inference _ DeepSeek R1, and we want to upload this file at this location. Just hit enter, and so the file is transferred. Now let's go back here and you can see that file here. Okay, so this is the file, and now you want to run this file, and to run this file what will you do? You will just write Python and then the file name. So see, here is the output. This is how you can perform fine-tuning. And I hope this video is helpful, and if you like my content, please like, share and subscribe my channel. Thank you for watching.